So if the voltage correction, if voltage corrective action is not applied, then voltage at various points, voltage at various stages of the system keeps on fluctuating, right? If the voltage corrective action is not applied, then voltage at various stages of system keeps on fluctuating. Second point, it is known that power system auxiliaries, or you can say power system components, operate satisfactorily only at the rated voltage. Any deviation from rated voltage value would definitely deteriorate the performance of the electrical equipment. Point number 3, it is known that all the electrical appliances, be it 3-phase induction motor, be it single-phase induction motor, be it 3-phase transformer, be it a single-phase transformer, be it a synchronous motor, right? So all the electrical appliances, they consist of copper winding. Winding means inductor, and it is the property of the inductor to consume the reactive power. Now this initial energy required for magnetization is nothing but reactive power demand of inductor, right? What I said, it is the property of the inductor to consume the reactive power, because it required some initial energy for its magnetization. So this initial energy required for magnetization of inductor is nothing but the reactive power demand of the inductor. Point number 4, reactive power is nothing but a mathematical concept, is a mathematical quantity in order to compensate the difference between the active power P and apparent volt ampere S. So if reactive power demand is equal to reactive power supplied, then voltage in the system would remain fixed and it would not fluctuate then. But if it is not so, then it will fluctuate. So it can be observed that whenever any large rating induction motor is switched on, it gives momentarily dips in the supply voltage. So in this paper, in this research paper, effort is made to boost the voltage using capacitor for inverter fed synchronous motor drive, right? At the time, point number 5, at the time of starting, induction motor works at low power factor and starting current is 5 to 7 times of the full load current. 6, these high starting currents may produce undesirable dips in the supply voltage and affects the normal operation of induction motor. 7, similarly, when we switch on any high rating electrical appliances, then tube lights dims momentarily. 8, motor drive can be DC drive or any AC drive, right? So we can choose any motor drive, be it a DC drive or AC drive in this research paper. 9, the DC drive has the limitation related to commutation and maintenance, so DC drive is not a good choice. 10, AC drive like induction motor or synchronous motor, is a good choice in a stern and challenging environment, right? 11, so permanent magnet synchronous motor has been chosen in this question paper. 12, power quality of supply is not always of good standards, because power quality suffers from various voltage related issues like over voltage or under voltage, right? So power qualities of supply is not always of good standards, right? Because power quality suffers from various voltage related issues like over voltage and under voltage. 13. Momentary voltage dips can affect the time response of the motor. Momentary voltage dips can affect the time response of the motor, and performance of electrical appliances gets seriously affected, right? Even due to slight dip in the voltage, right? Momentary voltage dips can be, I repeat, momentary voltage dip can affect the time response of the motor, and performance of electrical appliances get seriously affected even due to slight dip in the voltage, because electrical appliances are designed to operate satisfactorily only at the rated voltage. 14. Also, dip in the supply voltage hampers the maximum torque producing capability of the motor, as the maximum torque can accelerate and decelerate the motor faster. 15. Torque producing capability determines the transient torque producing capability determine the transient response of the motor drive. In this paper, low voltage ride through capability of the drive is incorporated at the DC bus of the inverter, right? So in this paper, low voltage ride through capability of the drive is incorporated at the DC bus of the inverter, right? So the 17. So the capacitor is controlled by power semiconductor switch, right? You see, this is the basic circuitry that we have worked upon. This is AC supply of 230 volts. This is single phase diode rectifier, LA, LB and C1, and this is the LA, LB and C1. This is the filter circuit to remove out the ripples in the DC output of this diode rectifier. This is the DC to DC boost converter. Here this is a 3-phase inverter. Output of DC boost converter has been given to 3-phase inverter, and output of 3-phase inverter has been given to the permanent magnet stepper motor. This is the control system. So this is V reference, or you can say V rated. So control system is having responsibility for connection or disconnection of this capacitance. This is V actual. So V reference is compared with V actual, right? So 17 is capacitor is controlled by power semiconductor switch. So this is power semiconductor switch. It can be MOSFET or any kind of switch, right? So the capacitor is controlled by power semiconductor switch such as IGBT, power MOSFET, etc. This is 17 point. Point number 18 is whenever there is a dip in the supply voltage, the control system senses this abnormal condition and it connects the capacitor by turning on the power semiconductor switch, right? 19. The figure shows the basic structure to address the problem of the low voltage or voltage dip, right? So AC 230 volt single phase diode rectifier, I have already explained this. 20. Power P is EF excitation EMF into terminal voltage divided by synchronous reactance XS into sin delta. Delta is angle between EF and VT. So torque is power by omega. Omega is radian per second speed. So you see that any dip in the terminal voltage VT will affect the torque producing capability of motor. Any dip in the terminal voltage, it will affect the power, and power will affect the torque producing capability of the motor. So the decrease in the maximum torque producing capability of the motor drive will make the transient response sluggish, right? So which can be improved by the proposed scheme in which the capacitor is connected to the DC bus at the time of low voltage. So once you connect the capacitor, right, then this capacitor will inject the necessary reactive power, so voltage will be maintained at this end, right? So capacitor is connected to the DC bus at the time of low voltage, right? So now thank you very much, thanks for watching.